All right, welcome to the next lesson on geometry angle theorems. Last lesson we talked about quite a few. This lesson we're only going to talk about 3 angle theorems. What makes these 3 angle theorems special though is they are for parallel lines only. So only where we have parallel lines can we use these. So how do we know if we have parallel lines? You'll know you have parallel lines if you have lines that are drawn. Let me just draw a couple here. Okay, there's a line. And there's a line, and somewhere on the line there has to be arrows, not necessarily at the ends. The ends have arrows showing that they continue maybe infinitely. But instead of hash marks, which we use like this to say that they're equal in length, with parallel lines we generally draw arrows like this. So I might say these two are parallel, or I could do a double arrow like this, or even a triple, like you can keep going, right? But the point is that means they're parallel. So you can see these ones aren't the greatest examples, but you can see there's tiny little arrows here showing that they're parallel, right? Or sometimes a question might just say they're parallel, or we have to know from the shape, like a square, right? Or rectangle, the opposite sides are parallel. We should know that. So if a question says we have a square rectangle, there you go. Or like a trapezoid where, you know, this is going to be a bad drawing, but you know, this side here and this side here are parallel, okay? So sometimes we also have to use our previous knowledge. Now, these rules really overlap each other. Generally speaking, in most scenarios, not all, but most scenarios, anywhere you can use one of these 3 rules, you can use all 3 of them. Usually 2, but sometimes you're only stuck with 1, but pretty much always you can use any of the 3. So you might find, well, you like to use one more than the other. All right, the first rule is, the short name is C pattern. It's called co-interior angles, but I like to just call it the C pattern for short. And so does, I'm sure, most people in math, because it just makes a C. It doesn't matter which way the C is facing, okay? The 2 angles inside the C, so here and here, have to add to make 180. So in this example here, right, that's 80, so this has to be 100. So the 2 of them make 180 degrees. So it doesn't matter which way the C is facing. So we could do the same C rule, like I could do a C facing this way, right? We still need all our old rules too. So you might start thinking, well, why would I use this new rule when I could still solve with my old one? Yes, you might be right in a lot of situations, okay? The next one is called corresponding angles, is its real name, but the easiest way to recognize it is the F pattern. So again, I've got parallel lines here, and I can basically draw this F. Now this one is the one people seem to use the least because they have the hardest time spotting it, but it can be used, again, parallel lines all over the place. So these 2 angles in the corners of the F, right, like this. If this is, oops, I'm going to draw an E. This is your F, right, where this is parallel and this is parallel. These 2 angles here and, oops, oh great, here and here are the same. So I could draw an F facing this way, right? Here's an F, right, facing that way. And if this is 70, this is also 70. I could also draw an F facing the other way, right? And you can do it upside down, whatever, you know, you rotate your page, the rule still applies, okay? It doesn't have to be a proper facing F, it's just the shape of an F. So if this is 110, this is also 110. So these angles don't add to make 180, they're the same. All right, now, some of you might be saying, well, couldn't I have just used my supplementary angle rule, right? That half circle rule here and half circle rule here. Yep, you could use that too, right? So now the rules really start to overlap one another. And there's multiple ways to get to the final answer. All right, the final one is called alternate angles, but its short form is the Z or Z pattern, right? This one looks like a Z or Z. This tends to be everyone's most used, I think, this and the C pattern. All right, so now the angles inside the Z. So if I draw it like this, it doesn't matter which way it faces. You know, I got it facing this way or that way. These 2 corners are the same, okay? So here's that Z or Z pattern, right? Like this, okay? So if this is 74, X is also 74. All right, so there's those 3 rules. Now what we're going to do is I'm just going to do some examples to show you them, you know, in action, what they might look like. Okay, let's do a few here. Looking at some questions. This first one's pretty simple. And you could really use the Z rule, the F rule, the C rule, it doesn't matter. So let's first remember opposite angles are equal, right? So if this is 77, B is also 77 degrees. So we got that. What else could we figure out? Well, we could use our supplementary angle rules, which is the half circle rule, and go, well, 180 in a half circle minus 77, so A would be 103. And then across from it would also be 103. All right, so all 4 of those angles we've got figured out. Now it turns out that these 4 angles up at the top are identical to these 4 angles at the bottom. Why? Now you can prove it using the C rule, the Z rule, the F rule. You don't have to use all of them. but any of them work. Remember, we have parallel lines here, right? We have these arrows here indicating it's parallel. Okay, so let's say we want to use the z rule. Okay, here's a z, right? Like that. So if this is 77, isn't this also 77? Yep. And then from there I could do my half circle rule, right? And go, okay, a half circle, right? 180 minus 77 gives me 103. So this would be 103. And then across from it's also 103, right? So there's C and D. They're all 103. And then the angle across from the 77 is also 77. So these are the same four angles, which is really common. If you keep an eye out for this, because it comes up in a lot of questions where you have like two parallel lines here and then an angle line cutting them, right? Traversing them, right? There you go. Now, you could use the C rule, the F rule, the Z rule. Let me just kind of draw on top and like think how we could use these different rules. Look, I could have used the C rule here. Inside the C, these two corners make 180, right? Well, 180, 77 plus 103 is 180, right? So that works there. I could do a C facing the other way, right? Like that. Inside that C, they have to add to make 180, and they do. I could use the F rule, right? Here's an F, right? These two corners have to be the same in the letter F. They are, right? You can do an upside down F. You could do an F facing the other way, right? Like this. This corner and this corner have to be the same. So the three parallel line rules all completely overlap each other. All right, and you can do a Z facing whatever way you want. This, I know it doesn't look like a Z, but this counts as part of the Z rule, right? There you go. Notice how the angles in these corners are the same, 103 and 103, okay? All right, so the next one's kind of the same idea. It's kind of hard to see here, but we got 110 in the corner. Here's A up here, here's B and C, right? Just go by what's on your page. Well, you could use the C rule, the Z rule, the F rule. If you want to use the C rule, look, here's a C. Remember, inside the C, the two angles have to add to make 180. So 180 minus 110 is 70. So C is 70 degrees. Now I could just use my half circle rule here, right? Half circle, half circle. I could find the other side using it that way. There's so many options once you start bringing parallel lines in, right? We could use the Z or Z rule and go, okay, well, here's a Z, right? So if this is 70, this is also 70, right? Where the C is, so on and so forth, right? So there's lots of different ways. So that means C also has to be 70. This is also 110. Again, you can prove it with a half circle, 180, right? 110 plus 70 is 180, so on and so forth, okay? All right, oops, I think I labeled that C in the wrong space, but it doesn't matter because they end up being the same thing. There we go. All right, next one. This one always messes people up first time they see it because they start using the rules from before. They start going, okay, I got a triangle here, and that does work sometimes, right? They go 180 minus 40 minus 35. What do I have? 105 here, right? And I got 105 here, and then they get stuck. So that's not going to help us. This is just using the Z rule twice. Watch. And you could do some other things. You could use the C rule. You could get really carried away, but this is the fastest way. Look, there's a Z or a Z, right? So if that's 35, that's 35. So there you go. There's a quick way of doing this one. Same with this. I could go Z, Z the other way, like this, right? And if this is 40 up here, this is also 40. There you go. Done. All right. Next one, the fastest way to just do this in one step would be the C rule. You could use the F rule or the Z rule, all kinds of stuff, but look, it's a C, right? Inside the C, they're not the same. They add and make 180. So this must be 60, because 60 plus 120 makes 180. All right, so keep looking for where you can use these, and it helps to draw on top of the diagram. Let's just look at a few more. Looks like 6 more here real quick, okay? All right, this one's a favorite of mine. You could use the C rule, the F rule, the Z rule. Remember, if this is 75, that's 75 across from it. We can do the half circle, which is 180. 180 minus 75 is 105, and this is 105. Now, remember what we just saw in the very first question? Just go back up to here. These 4 angles here, right, then they all make 360, are identical to these 4 angles here, right? So whether you like to use the Z rule, the C rule, the F rule, these 4 are going to be identical to these 4. So I'm just going to write them all in, and then we can kind of prove it one more time real quick. So this is going to be 105, 105, 75, 75. How do you want to prove it, right? Do you want to use here's a Z, 75 and 75. Those two corners there and there are the same, right? You could do a Z facing the other way. You could do a C. You could do an upside down F, right? Like this. Here's an F that's upside down, right? This corner and this corner have to be the same, right? Inside the F. So lots of different ways of proving it. But there we go. And then to finish it off, I got a triangle with 1, 2, 3 sides. So we still need those old rules. We're going to need them a lot. I got 180 inside every triangle, minus 105, minus 55. So that's what? 180 minus 160 leaves us with 20 degrees for x. There we go. All right, the next one here, number 6, is actually really similar to number 3 up here with the triangles, right? Look, 6 is another couple pair of triangles just kind of stuck together. There's a few different ways we could do it. Problem is, you know, this X is in a triangle with this corner, and this corner, but I don't know this corner. If I knew that, I could figure it out. Now, there's a few different ways we could solve this and fill in all kinds of different angles, but here's the fastest way, and just do it in like 1 or 2 steps. Let's use the Z rule. Parallel lines. Again, how do we know it's parallel? Don't forget, we're looking for these arrows. If they're not arrows there, we can't use these parallel lines. We're only allowed to use them when the arrows are present. So that's the other mistake. A lot of people start using them where they don't apply. So like here's the arrows here, right? We can only use these rules there. No arrows, no parallel line rules. Just use the other rules. All right, so Z rule that I just drew in, right? In green. The corners of the Z are the same. So that corner and this corner are both 25. And now we can just focus on the triangle at the top, right? You got 180 degrees in interior angles for any triangle. Minus 40, minus 25. So what's that? 180 minus 65. So that gives us 115 degrees left for X. There we go. All right, we got 4 more left to check out. I'm just trying to run through for you like an example of every kind of question that's ever been on a test for me, okay? And this is after these 4, it's the end of the lesson. Now this one, there's a bunch of ways of doing it. You can look at the big triangle, you can look at the little triangle, you could actually use the F rule upside down. There's 2 upside down F's. The first thing I spot is, look, big triangle. I'm just going to focus on the 3 corners. 1, 2, 3 corners of that triangle, right? Well, the 3 corners of that triangle have to make 180. So what's 180? Minus 60, minus 50, so that's 180 minus 110, 70 degrees. So this corner here is 70 degrees. So this is one way of doing it, right? Got that. Now, there's an upside down F, or you could actually use the C rule, but let's check out this upside down F I'm spotting. See the F right here? It's just upside down. These 2 corners in the F have to be the same. So if that's 70, that's 70. You could do an upside down F the other way, right? Some people might do this and go, if this is 50, this is 50, and solve it this way by using a little triangle on top. You could also do your half circle to figure out, right, what's this corner and what's this corner, right? We don't want to get too carried away, but the idea is sometimes you just got to start filling everything you can find in before you can find what you want. So just to finish it off in case it was helpful, right? I could use the C rule also, right? Watch this. Just want to show you different ways. I could use the C rule here. Here's a C, and there's a C on the other side facing this way. Remember, inside the C has to add to make 180. So 180 minus 50 is 130. And 180 minus 70 is 110. And then I could have solved by using the half circle rule here and here also, right? Lots of different ways. All right, next one. Well, I see this 40 here, and I know 40 across from this is also 40, right? And I could do my half circle here and go, well, what's 180 minus 40? That's 140. And that's across from that. That's 140. Look at all the angles. These 4 are going to be exactly the same as those 4 there. Now, how could I prove it? Favorite rule, probably the Z rule. Look, here's a Z, right? There you go. So this corner here, Y, is the same as that corner there. And then do my half circle, right? 180 minus 40, that's also 140. So maybe I'm going a little quick, but I know you guys, it can be pretty boring watching, so I know you can just rewind or pause and check stuff out. All right, 2 final ones here. All right, here we go. Now, what can we use on this one? This one's a little bit trickier. We're going to have to use the C rule because we don't have any numbers here other than the 2 in front of the A. So all we know is the A and the 2A. But what do we know about these 2? A plus 2A are inside the C, so they have to add to make 180, right? So what do you get when you get A plus 2A? That's 3A equals 180 degrees. Now divide both sides by 3. And what does A have to be? 60 degrees. So there you go. Now if I need the corners, this corner is 60. If I need this corner, that's 2 times A, right? 2 60s, so that's 120. And they add to make 180. So using the C rule there helped a lot. This last one really throws people off. It's tricky. Let's see here. The first thing I would start with is the Z or Z rule. I see that 50 degrees there, right? So see this? So if that's 50 there in that corner, this corner here is also 50. All right, so we get that out of the way. Let me get the Z going now. Now we have a triangle here, right? And the secret is it's isosceles. So which 2 corners are the same? Now this is the mistake everyone makes. Everyone goes, oh, this is 50 and this is 50, right? No, 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 right? Remember back to our isosceles page, right? The angles across from, not where they meet. So the angles across from the two sides are the same, but not where they meet are the same. So how are we going to figure this out? Well, we've got 180 degrees in every triangle, right? Let's subtract the 50 in this corner here, because we already know that. So what's left? 180 minus 50 gives me 130 degrees. Well, these two corners have to be the same, right? So why don't we divide that evenly between the two angles that are remaining? And what do we end up getting? 65 degrees for each of them. And there you go. All right, so these include a mix of parallel line rules and all the other rules we learned, right? But that's as far as we're going to go for this week. Try all the homework, okay? When you do your work, just show some rough work, kind of like I'm doing on the page. Write down some of the stuff you did. Basically, fill in some stuff on the diagrams. For a question like this, you can do what I did. Look at the rough work I showed here, right? Some work on the diagram. I just don't want to see this. I don't want to see there's nothing else, and all you got is that, right? If that's all you got and you didn't do any drawing on the diagram or any other extra work, I'm not going to give you credit. So show some rough work, okay? See, I've done a lot of rough work on a lot of these, right? It should look like you've been trying some work, okay? All right,